This video is about points that lie on a straight line, or colinear points. Now the points A, B, C there clearly do lie on a straight line. The points P, Q, R do not. Now that's obvious. We want to be able to prove this using vectors, and there are two key conditions that you have to meet for this. First of all, if I was to draw the vector AB there like that, and the vector BC like that, they are parallel. AB and BC are parallel. Whereas PQ and QR are clearly not parallel. So that is one key condition for our lines to be parallel. Now it's not the only condition. Just because we have two parallel lines doesn't mean they make a straight line. For example, if I was to draw the vector here AB and the vector over here CD, I've not drawn that very well, but even if I could prove that AB and CD are parallel, they clearly don't make a single straight line because there's no point joining them up. Whereas with this straight line here, they have a common point B. So that is our second key condition. They have to have, must have common point. In this case, B. Or I could work out the vector A to B. Then I could work out the vector A to C. And if I can show that they're parallel, they have common point A. So there are several different ways you can do it. You have to pick 2 points that are on the line, find the vector between them. Then pick another 2 points that are on the line, find the vector between them, show that they're parallel, and then talk about the common point. So let's have a look what that looks like as a GCSE exam question. So here I've got the triangle OAB. I've been told that the vector A to B is 2A. So this down here is 2A. And I've been told that the vector from A to O is 6B. So this vector here is 6B. So the whole thing there, I'm going to put it here and you'll see why in a moment, is 6B. I've also been told that AP is 2 parts and PO is 1 part, which means that this is 2/3 of the 6B. So if I split that 6B into 2/3, I get 4B, not A, 4B. And then this vector here will be 2B. I'm just splitting that vector 6B into the ratio of 2 to 1. So 4B and 2B. I've been told that Q is the midpoint of OB, and I've been told that B is the midpoint of AC. And I want to show that the line PQC, so PQC, I want to show that that is a straight line. Now to do that, I'm going to consider, first of all, I'm going to consider the vector PQ. Then I'm going to consider the vector QC. And if I can show that those two vectors are parallel, then because they've got a common point Q as well, that will show that it's a straight line. So I'm doing PQ and QC. It doesn't have to be. You could decide if you wish to do PC and QC. Show that they're parallel because they've got the common point Q. That would work. Or you might decide to do PQ and PC. Again, those are 2 points, 2 vectors that are on the line with a common point. So there's different combinations that you can pick. And depending on the question, sometimes one combination will be easier than another combination. Anyway, I'm going to do PQ and QC. So PQ, I can write that as being from P to O plus O to Q. Just let me highlight that on the diagram. So what I'm saying here is P to O plus O to Q. That will get me from P to Q. Now P to O, I know that is 2B. That's easy enough. 2B there. O to Q, I'm not sure what that is yet, but I do know that it's half making a mess. OQ is half of OB, because I was told that Q is the midpoint. So if I can work out OB, then I can half it, and that will tell me what OQ is. Now, OB, I know what that is because I can work it out like this. I can go from O to A, and then A to B. So that will be minus 6B, and it's a minus because I'm going in the opposite direction to that 6B, plus 2A. So if I half that, I get minus 3B plus A. So that is the vector from O to Q. That's this here as well. So if I write that down here, and now collect up these like terms, I get minus B plus A. So that's the vector PQ. I now want to work out the vector QC. Now QC, I can think of that as being from Q to B, and then B to C. Now QB, this vector here, is actually the same as vector OQ. This vector here is the same as this vector here because they're in the same direction and they're the same length because Q is the midpoint. So without any other calculation, I can just write the minus 3B plus A. The vector BC, across here, well, that's going to be the same as the 2A because I know it's in the same direction and I know that B was the midpoint. Now if I collect those terms together, I get minus 3B plus 3A. Right, now to write my conclusion. Remember what I'm trying to do here. I'm trying to show that this is a straight line. So I'm trying to show that these two vectors are parallel. And I can say here that QC, this, is equal to 3 times this. Hopefully you can see that's obvious. This is 3 times this. Therefore, PQ and QC are parallel and they share common point Q. Therefore, PQC is a straight line. And we're done. So with all of these questions where you're asked to prove that something's a straight line, you need to pick a combination of the vectors. Like I say, it could be PQ and QC, or it could be PQ and PC, or it could be QC and PC. It doesn't matter which combination you pick, as long as that those vectors involve the points that are on the line, and as long as they have a common point between them. That's all you need to be able to show to prove that to prove that we have a straight line.